Assalamualaikum and good evening. First of all, I would like to thank Dr. Gade as our lecturer in subject BBP 10402 Mathematics and all my fellow friends. We are from Group 11. Today, we will present our topic is real-life application of derivative. My name is Nur Ashkim Kusangim and metric number CB220131. As you can see on the screen, I will present about introduce. The derivative is a powerful tool in the solution of many problems in science, engineering, geometry, and economics. Among these problems, which you will find not only useful but also quite interesting, are those questions which call for maximizing or minimizing a function. For instance, a manufacturer is interested in minimizing the cost of his production. An engineer may want to determine the dimension of the stronger rectangular beam that he can cut from a singular log of 9 mm. A farmer may wish to find the area of the largest rectangular field which he can enclose with a given amount of flags. We should find that the derivative is a very useful in solving such type of problem. Thus, this module will help students to have knowledge of some of the application of derivative.
Okay, next, my name is Nur Amila binti Sulaiman. I would like to present the objective from the group project that we do. Okay, first, in physics, the derivative is extensively used in physics to describe the rate of change of physical quantities. In economy, derivatives are employed to study rate of change and margin effect. In engineering, that's engineers frequently employ the derivative. And in medical, apply to make sure of the tangent line the concept. In finance, financial market are large depends on derivative. In derivative, especially the concept of the tangent line to a curve, often known as the delta of an option, are the basics of financial instruments like options and futures.
My name is Muhammad Taufik Adalan and my matrix number is CB220138. Today I will present about type 1 subtopic about derivative of advantage. Advantage divided by 6 major points. One is rate of change, 2 optimization, 3 predictive modeling, 4 is control system, 5 is signal processing, and the last one is electrical engineering. For the first one, the relationship between quantity and another variable may be precisely measured using derivative. This is essential in physics and engineering to comprehend the rate of change of variables like velocity, acceleration, flow rates, and temperature gradients. Second is optimization. Derivative crucial in solving optimization issues. Engineering frequently have to maximize or minimize particular variable while taking limit into account. Engineers can improve design by using derivative to locate crucial location like local extrema maximize or lowest values. The third one is predictive modeling. Engineers and physicists can predict the behavior of systems thanks to derivative role in predictive modeling. Derivative aid in the forecasting of future trends or results based on the current circumstances by analyzing rate of change. The fourth is control system. In order to govern and stabilize reverse process, derivatives are often utilized in control system. Derivative feedback is used by engineers to react to change and make instant modification. Fifth, signal processing. Derivatives are used to analyze and manipulate data in industries like immigration and picture processing. Engineers can identify properties like photoelectric content, abrupt precision, and Next, level bifurcating the derivative of signal. The last one is electrical engineering. Electrical engineering relies heavily on derivatives to comprehend how circuit and electronic arts behave. They are used to compute power, impedance, and current voltage relationships. Thank you.
Hello, Assalamualaikum. My name is Nur Azrin Farina binti Muhammad Azhar. My matric number is CB220098. Derivative in physics and engineering. The derivative represents the rate of change between two quantities. It shows how one variable affects another in physics and engineering. For example, the derivative of position with respect to time gives velocity. Derivatives are used to analyze system behavior, like voltage and pressure change. They provide insight into variation and interaction of quantities. Derivatives are essential for understanding and solving problems in physics and engineering.
Next is derivative in electrical engineering. Derivatives are used to describe the rate of change of various electrical quantities, such as voltage, current, and power with respect to time or other variables. Derivatives play a crucial role in analyzing and understanding electrical circuits, systems, and signals. Application of derivative in electrical engineering. First, voltage and current derivative. For example, the derivative of voltage across a capacitor with respect to time gives the current flowing into or out of the capacitor. Second, power derivative, such as when switching on or off a circuit, as it helps us understand the power dynamics during this transition. Third, signal processing, such as edge detection, differentiation, and time-varying filtering. Fourth, control system. It used to calculate the system's error or the difference between the desired and actual outputs. And lastly, electric machine, used to determine the motor speed or to estimate the motor rotor's position.
My name is Ahmad Firdaus bin Amar. So my number matric is CB220007. So as you can see, my part is in discussion, and we have gathered a few questions about derivatives. So the first one is, find the equation of a tangent to curve y equals to x power of 4 subtract 6x power of 3 plus 13x power of 2 subtract by 10x plus 5 the point 1 and 3. The equation have been given is y equals to x power of 4 subtract 6x power of 3 plus 13x power of 2 and subtract 10x plus 5. As we know, the given coordinate is 1 and 3. So, as we know, the slope of the tangent at any point, say x1 and y1 to a curve is given by m equals to dy over dx, or x1 and y1. dy over dx equals to 4x power of 3 subtract by 18x power of 2 plus 26x subtract by 10. The next step is m equals to dy over dx, or 1 and 3 as the coordinate have been given, equals to 4 times or multiply by 1 power of 3 subtract by 18 multiplied by 1 or power of 2 plus 26 multiplied by 1 and subtract by 10 equals to 2. So the slope of the tangent has been given at the curve 1 and 3, as the coordinate says 1 and 3 is 2. So as we know, the equation of the tangent at any point, as I stated earlier, is x1 and y1. So is given by y subtract by y1 equals to dy over dx, and x1 and y1 and x subtract by x1. So here x1 equals to 1, y1 equals to 3. So substituting these values in the equation is y subtract by 3 equals to 2 multiplied by x subtract by 1, and lastly you can get is 2x subtract by 1 plus 1 equals to 0. The next question is if radius of a circle is increasing at the rate 0.5 centimeter per second, what is the rate of increase of its circumference? And rate of change of x is given by circumference of circle is 2 pi radius, and the calculation is here 0.5 cm over second, and circumference of circle c equals to 2 pi r. Now taking the derivative on both sides, we can get 2 pi multiplied by 0.5, and you can get pi cm per second.
Okay, lastly, in conclusion, derivative is calculus serve as a powerful tool with wide-ranging application in physics and engineering. They allow us to analyze rate of change, providing insight into dynamic phenomena such as motion, kinetic, and system behavior. Okay, by employing derivative engineering can optimize design, control system, and analyze electric circuit. They also play a role in signal processing, enhances communication system, and medical imaging technology. The ongoing application of derivative in their fields continues to drive progress, innovations, and advance towards a more effective and technology advanced futures. That's all from our groups. Thank you.